Part A, state what is meant by the term secondary alcohol. A secondary alcohol is an organic compound where a hydroxyl group is attached to a carbon atom that is bonded to two another carbon atoms, or you can say alkyl groups. Part B, give the name of the additional piece of equipment needed when heating the reaction mixture for this length of time without any loss of mixture. In this kind of heating of volatile substances, or even sometimes prolonged heating of aqueous solvents, we include a reflux condenser to minimize the loss of contents in the system. Describe the color change that occurs during this heating. We are starting with dichromate iron, which is having a bright orange color or vibrant orange color, and it is getting reduced down to chromium 3 plus with a green color. So the color change would be bright orange to green. Describe how the IR spectrum of reaction mixture would change during this reaction. Your answer should consider only the organic reactant and product. The organic reactant here is alcohol group, which contains carbon oxygen stretching and carbon hydrogen stretching respectively at 1000 to 1300 and 3200 to 3600 per centimeter, and these are going to be disappeared from the IR spectrum of the propanone. And in the propanone IR spectrum, you can see an additional C double bond O stretch which lies near 1700. Carbon hydrogen stretches almost do not change. Part C, the cumene process is shown using molecular formulae. Benzene plus propane, propane becomes cumene, and cumene plus oxygen, you get phenol and propanol. Calculate the mass of benzene in kilograms needed to produce 2000 cubic decimeters of propanone using cumene process. You should assume that the overall yield of the process is 85%, and density of propanone is 0.784 grams per cubic decimeter, cubic centimeter, that is equivalent to 0.784 kilograms per cubic decimeter. So I'm going to use that value to get the mass of propanone required in kilograms. I can calculate, if I take in that way, I can calculate it directly. So simply I have to multiply 2000 cubic decimeters by 0.784 kilograms per cubic decimeter. Then that mass, to get that mass, since the yield of the process is 85%, to get that mass, we have to produce more. So to find how much exactly, we can multiply that value, the mass required, by 100 and divide by 85. Then we can get a ratio between benzene and propanone. By stoichiometry, it is 1 to 1, and by mass, it is 78 to 58, the molar mass ratio. Then I can calculate the required mass of benzene in kilograms, the required production of the theoretical yield required out of propanone times 78 divided by 58. So I'm getting a value of 2480.8 kilograms as the mass of benzene that I have to start with. Most chemists would say that step 2 of cumene process has an overall percentage atom economy by mass of 100%, even though there are two products. State what can be deduced from this comment. Okay, let's go back to the step 2 and see. If you carefully look at the thing, propanone mass is very low compared to the other product, but still the chemists are saying that it is a 100% efficient, 100% atom economy process. Carefully look at the question. They are not specifying what is the desired product. So when it comes to industry, the processes, when we are selecting the processes, we are looking at the byproducts also. If you look at the byproducts, or when if you consider the propanol as the main product, look at the byproduct is phenol, which is also having lot of applications in the industry. So we can say, as the desired product of the industrial process is not specified, both the products can be considered during atom economy calculation. Both the products, propanol and phenol, are widely applied industrial chemicals. Therefore, the reaction can be assumed as a zero waste process where atom economy is 100%.